On the way to the zero-emission construction site, we're undergoing two transitions: the energy transition in general, as well as the technology transition to emission-free machines. The energy transition involves us moving from an energy system based on fossil fuels to a system based on renewable and emission-free sources. With the technology transition, we're moving from the combustion engine with a mechanical powertrain to an electric powertrain. Although both transitions are comprehensively interlinked, they can also be considered separately. And in the current phase of the energy transition, that is even advantageous. The electricity grid in the Netherlands has reached full capacity. It's very difficult to get more grid capacity at a construction site or for a home. At the same time, the development and availability of electric equipment is increasing by leaps and bounds. Thus, the energy transition is lagging behind the technology transition. This is why some contractors are not buying electric equipment now, because it's impossible to charge due to the deficit in grid capacity. But buying a new machine with an internal combustion engine is not a good idea either. These machines have an average lifespan of 8 to 12 years, and there is a growing possibility that this equipment will soon be banned from use. More and more places have restrictions on local emissions of nitrogen oxide or particulate matter. Permits for nitrogen oxide emissions are already very hard to come by. Given the faster technology transition, it makes more sense to purchase electric construction equipment now. If electricity really cannot be arranged at the construction site, installing a clean diesel generator set is still better than using a diesel machine. A clean generator set produces fewer emissions because of its constant speed. Moreover, you can immediately build emission-free as soon as clean electricity does become available, and that might be on the very next project. There is a logical prioritization to get power to a construction site, despite the fact that temporary, high-load grid connections are hardly available currently. First, look at the nearby companies that are not fully utilizing their grid capacity. This capacity is readily available and does not cause additional grid congestion. If that fails, option 2 is to establish a grid connection that remains available for public benefit after construction work is completed, such as public charging stations. If that too is not an option, consider an autonomous energy source in the form of a renewable generator set on green hydrogen or biogas, or work with exchangeable batteries that you charge somewhere else. The last possibility is to establish a temporary grid connection at low capacity specifically for charging construction equipment. In combination with a buffer battery, this provides 1 megawatt-hour of power per day at minimal grid congestion. This logical prioritization helps us proceed with the technology transition independently of the energy transition. Much is already possible in the field of renewable energy, and project-specific solutions already minimize the use of generator sets. Electric equipment is thus always better than internal combustion engine equipment.